So the way this review is going to work is on the left-hand column of all your papers, there's a we do problem, which means you're going to watch the video on how to complete that problem. On the right-hand side is the you do. When at the end of class, you're going to have to turn this in, and we're going to be checking the you do problems. They mirror the question right next to it. So question number 1 on the left is very similar to question number 1 on the right. I would also have some highlighters and my foldable out because that's what you're going to be allowed to use on your test. So in number 1, if you look at rhombus ABCD, if the measure of angle DAB is 110, what is the measure of angle ADE? The first thing you want to do is start by labeling your picture. So the measure of angle DAB, A is the vertex there, so you want to zone in at A and find DAB, which is this whole angle right here. So that angle is 110 degrees. We need to find the measure of angle ADE. ADE. So D is the vertex there, so you zone in, ADE is this guy right here. So that's what we're looking for. Some of the properties of quadrilaterals and rhombuses that you need to use is that these diagonals right here are intersecting at a 90-degree angle. So you know that's 90 degrees, so you could either put the little square there, or I think some people think it's more helpful to actually write 90 in there. And then the diagonals also bisect the angles. So this 110 gets split in half, which is 55. So the little piece there is 55. From there, it's just the missing angle of a triangle. If you need me to redraw, you have A up here, you have D, and then you have E. We know that's 90. We know that's 55. That totally looks like a 55. And you're missing this guy. So, just like we've done in the past, you add up what you know. 55 plus 90 is 145. And then you subtract 145 from 180. And we get, oops, don't do 195. $35. So the measure of angle ADE is 35. So I'm going to write my answer nice and pretty, and I'm going to circle it. Okay? Alright, moving on to number 2. You have circle O, which means O is the center of the circle. If the measure of arc CB is 80, so you want to label that. What is the measure of angle CBA? So angle CBA has a vertex of B, which is, so the angle is right here. What you want to notice is that there is a segment that goes through the center of our circle, which means you have a diameter. So segment AB is your diameter, which means it's splitting the circle in half of 180 degrees, and one of those angles is 90. So since angle C makes that arc, angle C is the 90-degree angle, and then you can find angle A because it's an inscribed angle and it makes the 80-degree arc. So angle A is 40 because the angle is half the arc. And from here, you just have to find the missing angle of a triangle. So I will redraw the triangle to help you see it a little better. So we have A, C, B. So C was the 90 degrees, A was the 40, and B is the angle we're trying to find. Okay, so add up what you know. 90 plus 40, which I believe gets you to 130. I did my math correctly. And then subtract that from 180. Aren't you glad we learned about triangles first? And you get 50. So the measure of angle CBA is 50. The key to this problem is recognizing that this lovely guy is your diameter. And then recognizing that C is that 90-degree angle. Okay? All right. Last but certainly not least, number 3. What is the measure of angle what is the measure of arc XY? So arc XY is right here. So we don't have too much information, but we have enough information because we have an inscribed angle right here. That angle is making this whole arc. Okay? And we already know a little piece of it, and we need to find the missing piece. So the angle at angle Z makes an arc WY. The arc's measure is 69 times 2, which is 138. So the highlighted portion right there, total is 138, but we only need that little orange part. So we really only need, I'll make it green now, this part. So you have the 138 and take away what you know to find your missing part. 100, which means the measure of arc XY is 100 degrees. Number 2, this should be the easiest question on your test. What is the magnitude of the smallest counterclockwise rotation that maps the figure onto itself? So how many degrees would you have to turn this flower in order to get it right back onto itself? That's a 2 there if you didn't know. So do not make a mistake of counting the petals incorrectly. And then all you do, 360 divided by 8, because there's 8 petals. Sorry if I got a little too excited there. 45 degrees. Do not get this question wrong on your test. I want everybody to get it right. Okay? Alright. Next, figure ABCDEF is a regular hexagon inscribed in circle O. What is the measure of OFD? Alright. I'm going to use the actual straight line tool. So, OFD. Okay. So, we have done this problem very similar to it where we've actually drawn in all the diagonals because that's going to help us with our numbers. Okay? And the angle that we actually need to find is just one little sliver right there, whatever that one sliver is. Okay? So since it's a regular hexagon, we know that the sum of all your interior angles is 720. You divide that by 6 to find the measure of each angle. So all of these bigger angles are 120. What's happening here is using the diagonals, we've split it into 4 equal parts. So we need to divide the 120 divided by 4 to get 30. So each little part is 30 degrees. Now, looking at the angle we need, we only need one of those parts, and one of those parts is 30 degrees, which means our angle is 30 degrees. So there's a very similar question like this on your quiz where a lot of you guys added 30 and 30 to get 60. We only need one of those sections. That's why we just leave our answer at 30. Okay? Okay, last question on this page. The exterior angle to the vertex angle of an isosceles triangle, which means you have 2 equal sides and 2 equal angles, is 39 degrees. What is the measure of one of the base angles? So we are trying to find these guys. So you could use this rule as, you know, inside, so in plus in, oh dear, let me write that a little neater. In plus in equals out. So we happen to know that it's an x and an x equals 39, which is just 2x equals 39. Therefore, x, or one of our base angles, whatever 39 divided by 2 is, 19.5. You could do it that way, or I'll show you a different way to do it. You could have found that guy right there. So that guy and 39 are a linear pair. So 180 minus 39 gives you that guy, 141. Then you can use what you know about triangles, whoa dear, and say, hey, I got a 141 degree angle already. So take that away, which gets you back to 39. And then you know that you have 2 equal angles, which is why you divide it by 39. Either way, you get 19.5. Okay? Right, moving on to the next page. KIT is a kite. So I return to the kite foldable section of your notes. So they've given you a lot of information. They want us to find ICT, so I'm going to do my best to color code. So C is the vertex. So ICT, that is where the diagonals meet. So the diagonals of a kite are perpendicular, which means the angles form 90 degrees. Okay. Next up is IKC. The vertex of that is K. So IKC. Alright, so if you're looking at this as one little triangle, you know that one of the angles is 58, one of the angles is 90, and you got to find the missing angle. So add up 90 and 58. That gets you to 148, and then subtract 148 from 180. And you get the 32. Okay? Now the measure of TEC. TEC. Alright, well you know that top angle right there is 72. This guy is 90 because it's where the diagonals meet. So TEC is the missing angle of a triangle with a 90 degree and a 72. So add those to get 162. Subtract from 180, 18 degrees. Little angle. Okay. And now the measure of IKE. IKE is that whole angle. And you know that that guy is 32. There's a symmetry line here of a kite. So this guy is 32. So the whole measure is 64. Okay? And now the perimeter just means to add up all the sides. So KE is 13.2, which means IK is 13.2. And IT is 8, which means TE is 8. So if you add all those sides together, you get 42.4. meters. Okay? Alright, everybody's favorite question. Shout out to Daniel, because on some assignment Daniel said he needed help with this type of problem, so this one is dedicated to Daniel. Okay? The first thing you want to do is label your angle. Angle W is 32 degrees. We're going to be using isosceles triangles here. So, you use the angle, now you want to use the sides. Side WX is congruent to side XZ. So these are congruent angles. The base angles at the bottom across from the opposite sides are equal. So that guy is 32 as well. Now you need to find the missing angle. So add up 32 plus 32, subtract that from 180, 116. Okay, now you can use linear pairs to find this angle. So 180 minus 116 will give you that angle, 64. And now I'm going to use the fact that side XZ is congruent to side YZ. So then now the 64 is also up here because they are across from congruent sides. Then find the missing angle, 64 plus 64, subtract that from 180. This guy is 52. Okay? So the angle that they want us to find is WZY. WZY is that whole angle. So you end up adding 32 and 52 to get 84. So the measure of angle WZY is 84 degrees. Ta-da! Alright. Next, regular pentagon. Penta. Imagine that. It has a name of penta. Draw the pentagon. I typically just draw my pentagon. Ooh, Miss Bailey is popular. She is getting lots of text messages. Okay, so I draw my pentagon just like a house. P-E-N-T-A. It's regular, so all of the angles add up to 540, and each of the angles are whatever 540 divided by 5 is. I believe it's 108, but always good to double check. 108. Okay, so every angle here is 108. So 108, 108, 108. And we have to find the measure of angle P. Ha ha ha, not P, P-E-A. Get it? Okay, so draw your diagonals in. And you knew to start at E because E was the vertex. So basically, this is the angle that we want. So it's just one of those little slivers. And the diagonals divided that angle into 3, so you have to divide 108. Divided by 3, I believe it's 36. Hot dog, I know my math. Secretly using a calculator. So each of these little slivers is 36. 36. And we only needed one little sliver, which means the measure of our angle, PEA, is 36 degrees. Alright, I believe we have one more paper. I'm going to see if I can make this. Whoa! Alright. In the figure at the right, segment AB is the diameter of the circle, which means this is 180. Okay, and that angle is 90. If the measure of arc AC is X, what expression represents the measure of angle A? Alright, this is a tricky question. It's not my favorite, but it's a math god type question. So let's see. You know that basically this half this. So this arc right here is 180. But the other thing is, this arc right here is also 180. Okay? You already know x of it. So the measure of arc CB is going to be 180 minus x, because if we knew x, we would just take that away. Okay? And then they want the measure of angle A. So you want to think, is that essential or inscribed? And it's inscribed because A is on the circle. So you would be taking half of whatever the arc is. So it's going to be half of 180 minus x. Now, the math gods are going to want you to distribute this. So half of 180 is 90, and then half of x is just going to be x over 2. It's a kooky question, but, you know, some people got to do it. So that would be your answer. Okay? All right. Number 11 is super doable. Do not get it wrong. You have an isosceles triangle, which means at least 2 angles are equal. They tell you the equal angles. Okay? Now, x is representing side lengths here. Do not use 180 because we do not have the angles. All we know is that this side is equal to that side because they're across from the congruent angles. We are not adding these up and setting them equal to 180. We are setting them equal to each other. Okay? Whoa, Miss Bailey. So 4x equals 18. X equals, whoa, not 45. 4.5. Okay? Please, please, please do not get this type of problem wrong. On your test, it might ask you for the actual side length, so you'd have to go back and use x. Alright, I think this is our last one. Alright, in a rhombus, REJD, the measure of angle DRE is 82. Shout out to Dr. Dre. So, DRE, 82. That's the big angle right up there. Okay? You need to open up to rhombus rules. Alright, so the measure of DRA. The diagonals bisect your end angles. So DRA, which is right here, is 82 divided by 2, which is 41. Okay? You needed to put that label in, go ahead. Then RDA is this guy. So now you got to use that this is 90 because the diagonals of a rhombus intersect at 90 degrees. So you have a 41 degree, a 90 degree, add up what you know, subtract from 180. 49 degrees. Okay, DJA. So you could go the long way and say that, hey, this angle is also 49 degrees, and you could add up, subtract from 180, or you could say it's opposite the same angle. So you had 41 down here, so you have 41 down here. And then DJE is opposite that 82 degrees, so it's the whole 82 degrees. You need to be using the properties. I believe that concludes the tutorial on how to do all these problems. So hopefully you watched the whole video. If you made it to the end, congratulations. So now you need to complete the your turn problems, and if you finish that, you turn it in and you have quadratic formula practice. Ta-da!